Hello guys, today I am going to talk about quicksort. Now, what is quicksort? So, quicksort is a sorting algorithm that excels at efficiently organizing large datasets. It follows a clever strategy called divide and conquer. Now, what is divide and conquer? Divide means it picks an element from the list and calls it a pivot. Now, what do we mean by conquer? It rearranges the list so that elements less than the pivot are on the left of its side and elements greater than the pivot are on its right side. Now, after combining those two subsets, we will get our final list. Now, how quicksort works? The key process in quicksort is a partition. The target of the partition is the place the pivot. Any element can be chosen to be pivot at its correct position in the sorted array and put all smaller element on the left of the pivot and the greater element to the right of the pivot. Partition is done recursively on each side of the pivot after the pivot is placed on its correct position, and this finally sorts the array. Now, choosing a pivot. There are many different choices for picking a pivot. Now, let's talk about four of them. First, always pick the first element as the pivot, means the leftmost element as the pivot. Then, always pick the last element as the pivot, like the most right hand side element as pivot, and we will and our code is implemented on this only. Now the third one, pick a random element as a pivot, means pick any element which is inside our list. Now pick the middle as the pivot. Whenever we have a list, we can also choose the middle part as our pivot, and then we will have two subsets. Now moving on. So here's our code for partition. First we are taking three parameters as array, its lower and its higher. The lower and higher are indexes, not the elements. Now we will take pivot equal to ARR high, means the pivot will be the last element of our list, and we are taking I as our low. So here I is low minus 1. Why? Because we will tell you. In the next line we are using a for loop where j is equal to low. So I is lower than j. So j equal to low, and j, while j is less than equal to high minus 1, j increments by 1. Okay. So here we check by ARR of j is less than or pivot or not. If it's less, then I increments by 1 and swaps ARR by j. Okay. And then after this whole loop ends, we swap ARR of I plus 1 with ARR of high, means the last element with the ARR of I. And in this, after this partition, we return I plus 1. Now moving on to our quicksort function element. Quick, now moving to our quicksort function. So this function basically uses partition as its function and then recursively calls itself. Now, first, the parameters here also are ARR, low and high. So while low is less than so if low is high, if low is less than high, the pi, means the pivot, is equal to partition ARR of is equal to partition ARR low and high. Now we will call this function recursively, while first we will use pi minus 1 as our high, then we will use pi plus 1 as our low. Okay. Now moving on. Now let's discuss about the time complexity and space complexity of the quicksort. Now first we will talk about time complexity. The best case of the time complexity for this quicksort is ohm of n log n. The best case scenario in for quicksort occur when the pivot chosen at the each step divides the array into roughly equal halves. Means if the pivot divides the array in a roughly equal half, then this that case is our best case. In this case, the algorithm will make balanced partitions leading to efficient sorting. Average case, where theta of n log n, it's same as our best case. Uh, Here, the quicksort's average case performance is usually very good in practice, making it one of the fastest sorting algorithm. Now, let's talk about the worst case, where it is O of n square. Now, the worst case scenario in quicksort occurs when the pivot at each step consistently results in highly unbalanced partitions. Whenever the pivot divides the array in unbalanced partitions, it is our worst case. Now, when the array is already sorted and the pivot is always chosen as the smallest or the largest element, to mitigate the worst case scenario, various techniques are used, such as choosing a good pivot like median of 3 and using a randomized quicksort to shuffle the element before sorting. Now let's talk about the auxiliary space complexity. It uses O of 1 as it doesn't uses any other space. Like if we don't consider the recursive stack space, if we consider the that's for O of n. Now if we consider recursive stack space, then in the worst case, quicksort would make O of n. Yeah. Now let's moving on. What are the major advantages of quicksort? It is a divide conquer algorithm that makes it easier to solve problems. It is efficient on large datasets, like its use on very large datasets. It has a low overhead as it only requires a small amount of memory to function. Like I told, it is very good for space complexity. Now, what are the disadvantages of quicksort? It has a worst case time complexity of n O of n square, which occurs when the pivot is chosen poorly. It is not good. It is not a good choice for small datasets. Like we can go for other algorithms rather than quicksort for small datasets. It is not a stable sorting algorithm, meaning if two elements have the same key, their relative order will not be preserved in the sorted output in case of quicksort, because here we are swapping elements according to the pivot's position without considering the original position. Now, that's all from my side. Thank you and have a nice day.